Hi everyone. Good evening. Welcome back. Welcome back to 360DigiTMG channel. And like every week, this week also we have brought in a presentation. The project is about tracking the performance and monitoring the performance of the machine in a manufacturing sector. And we have Tableau team. The dashboard development and the prediction has been done in Tableau. We have highlighted the machine's performance when it goes below a threshold level. And this is done using the IoT sensors data. And we have Salma, who will be taking over and explaining about the project. And congratulations team to successfully accomplish this project. And please take over, Salma.
Yes, thank you, Sharath. Hello, everybody. I hope you were able to view my screen. Okay, let's quickly start up. Thank you, Sharath, for introducing and then explaining the brief about the project. Just a few seconds, guys, before I open the presentation for you guys. Yes, guys, I just want to start off and then introduce the team. We are 10 members in the team, and then our project manager is Sharath, and then we have Sandeep as our mentor. So this is the team who has worked on the project, and congratulations to you, all of you guys. And I really appreciate the good work and then the effort you have put in for this project. So to start up the goals and objectives of this project, like Sharath has mentioned, the overall goal is to visualize the bottling plant machine performance. Obviously, it is time series data, and then visualize it in the Tableau platform so that we identify the potential opportunities. I'm sorry, guys. Can everybody?
Can everyone be on mute, please?
Yes. Yes, guys. So the goal of the project is to ensure that we identify the potential opportunities so that we can predict, we can take the corrective actions whenever there is a maintenance issue. Okay, that is the project goal. So what are the objectives of this project is objectives, and then the steps what we have followed is just upload the input and output data in CSV or Excel files to Tableau desktop and analyze the input data, the blower and labeler. I'll probably talk through these steps. What is a blower? What is the labeler in the next slide? And forecasting the input data and analyzing the output data. It is an hourly, obviously, like it is a time series data. So we analyze the data in hourly, daily. It could be a monthly basis, and we are going to develop the interactive dashboards and stories for both input and output data, which can briefly tell us and then showcase us how the data looks like. So this is a project goal and then objectives. So I'm just going to move on to the next slide. Yes, so here we see the architecture, the process what we have followed. Like Sharath has mentioned, we get the readings of the real-time data from through the IoT sensors. Right, so there are different approaches. How do we get the data into Tableau and then showcase the dashboards and the stories? So the ideal way of doing it is taking the real-time data through IoT sensors and then uploading it into the Influx database, then create a model to Python, obviously by using the forecasting method there, and then deploying it in the Flask application and then connecting it to the Tableau. This is the ideal way of uploading the data in Tableau and then performing showcasing the dashboards and the storage. But as it is not a live platform, and we have considered taking the CSV file, and that's what the architecture diagram shows here in the top. How do we upload the CSV file and then use the native forecasting methodology in Tableau application to showcase the forecasting and then create the dashboards and the stories. Right, so moving on to the next slide. I'll probably, yes, take this through as a challenge, because as I said, there are different ways to upload the data to Tableau. It could be even through InfluxDB, or it could even be uploading directly through CSV file. So just for your little more knowledge, that so if we have got the knowledge of Node.js language, so it will be very easy to connect the data through web data connector. I think this is for somebody who is from the developing background. This is just an option, but I would still suggest the ideal way of connecting data is by deploying it in Python and then connecting it through the Flask application. This slide talks about the implementation approach. How did we start, and then what did we do, and then how did we end up achieving what is required from this project. The first one was the first step was we used the input data beverage file for the input data analysis, and there was an output data file was also which was taken for the analysis. And then with the input data, whatever was there, we have forecasted using native forecasting of Tableau. Then we have created multiple control charts, eye charts, moving average charts to measure the performance of input, so that we can come out of the inferences and ideas what's happening with the data. And yes, all null values will consider as 0, and all interactive dashboards and stories were created with the analysis, whatever we have performed with input and output data. Okay, so this is just an overview before we could go into the dashboards. The next slide talks about the input data. So what is that? I'm just going to quickly take you through, guys, how the charts look like, and then explain little about what exactly these slides meant. Then we'll jump into the live platform of Tableau, where I'll probably show it to you and then explain in depth. Then after that, we will probably take up whatever the questions you have. Right. So this slide talks about the input data. So ideally, before I could talk about the charts, I just want to tell you, as it is monitoring performance of the beverage, or maybe some, just imagine, I'm just gonna make it easy for you to understand it, is soft drink. So ideally the process goes through different machines. Okay, it will probably first go through the blower, then it will filler, and then the labeler, and then probably go to the output. So there are so many different stages, different machines what the bottle have to go through to obviously come into the output stage. So currently we are going through only the 2 stages. One is the blower, obviously that's a one machine, and then the labeler, which will obviously label the bottle. Right. So here the first chart talks about the blower input data, the blower performance into the hourly. This is hourly data. So x-axis you will see the hourly data, and then the left side, the y-axis, you will see the readings, whatever we discussed in the previous slides. These are the IoT sensor readings, right? So the first chart talks about the performance of the blower, and then in the left side, we even have forecasted the blower performance, and then the right side we have same presentation, but it is for the labeler. That I will of course talk in depth about what is this charts, and then you will understand it in a better way when I will show it in the Tableau dashboard. But just to know that this is a blower performance in the left side, and the right side is a labeler performance. And what is this 2 days, 12 hours and 24 hours is nothing but how is the machine performing in a 2 days. And we have an interactive dashboard where you can even see the machine performance for 12 hours, for 24 hours, or you can even see the performance of the machine for the 2 days in the same view of the dashboard. So that's what this slide talks about. Okay, this is input data all machine comparison. What we are trying to showcase here is when there is a this is obviously a monitoring bottling performance in every machine. So there are different machines the bottle has to go through, which the names of the stages or the machines have been given here in the left axis. So the what's first is a filler, labeler, blower, and then CO2 part. So these and all the machines, and then the right the x-axis we have taken the time, obviously, as we are tracking the performance of the machines against the time. So this is like overall view of machines in the same slide, which obviously we can come up some inferences here. The labeler has a similar performance with the filler. Nothing but these two are linked together. Nothing if there are issues is found, obviously we can see that there is a similar kind of issues will be found in labeler and filler, so that we can if there is an issue with the labeler, obviously there will be some issue with the filler here, same. And the same with the blower and preform. These are the two stages, two machines. We can see there's a similar trend with these two machines as well. And we can see CO2 have a downward trend. This is something we can observe how the machine is performing. And then there are two other stages have a similar performance. This is just to see what is the overall performance of all the machines on the same slide or the same dashboard. Right. Then moving to the next slide. This is a blower and labeler comparison. The blue color data shows here the labeler, and then the orange one shows the line chart shows the blower performance here, some of the blower performance, and the against the readings, the time series data. So what is it we inference here is obviously the labeler has got more stoppages or erratic performance compared to blower when you see zero values here. So that's what we can inference from this chart. Okay, this slide just an overview of, we have created the animated view of blower and labeler performance with the input data. So this slide just shows the view of the animated charts. Obviously, we will get more understanding when I see it in a Tableau application, what is exactly we can inference from this chart. Right. So this is the last slide for input data. This is like unified view of the dashboard. So for example, if some monitoring team can see this screen and can understand if there is any issue. This is just a unified view of all hourly performance and blower performance, and even though you can even compare the performance of labeler with the others machine, which is a CO2 machine. So this is a dashboard view, or I would say the unified view for anybody to see and monitor what's happening with the blower and the labeler stage. Right. So this is with the input data, guys. And then the next slide is we are moving to output. Right, so this chart is a control chart. We have used a statistical approach to come and then on this chart, and then which clearly talks about the average line and then upper control limit and lower control limit. So we have used a multiplier here to with the standard deviation to arrive at the outliers. I would say that that is something which is out of control and out of control. Nothing but here, whatever you see with the labeler, the left side, you see these are some points where the labeler has a problem, and then here the right side you can see there are some points, some readings where ideally the blower has a problem. Right. So as I said that we have used this SPC method here. There is different stages of SPC level. You can choose 1 6 sigma and then 2 6 sigma. Obviously, we will talk in depth about the level of sigma we have used in the when I'm showing the dashboard to you. This is one more story we have created with the output data. As the previous slide, we have used the SPC methodology. Here we have used a reference band with the confidence interval to see the performance of the machine. The left side is the blower, and then the right side talks about the labeler performance. And you can see here when we are considering the hourly performance of the blower, where the stoppages are, and then here the right side. you can see in the hourly performance of the labeler. And then this is like a little similar like what we spoke in the input data as well, where labeler has got more stoppages and more issues compared to blower. So this the first chart talks about the reference band and then the hourly performance, and then we have added the moving average and running total also to see how is the machine performing in both the stages. Okay, moving to next slide. This is a dual axis control chart where you can see how is the blower performance against the labeler. This is the same thing we have shown for the input data as well. We can inference the same way that the labeler has got more frequent stoppages and then more downtime than the blower stage. So this is again a time series data where we have taken the sensor readings and then trying to create and then show what is the problem and where is the problem, so that we can go back and then find out and then the monitoring team can find out and then probably stop the production and then see what is the fix they can come up with. Right, so the next, this slide talks about the animated view of output data. We will go in depth and then probably I'll show it to you how this works and then what kind of inferences we can get in the dashboard view. Yes, like we have unified view for the input data. The same way we have created a dashboard where you can see you can have a unified view of all the charts. I mean, for when it is a blower and then labeler stages, you can probably see. And then if you can in a live environment, whenever there's a data is uploaded in the cloud, and then you can connect this to Tableau, so you can actually see the live performance. You can track and then quickly identify if there is any problem with these control charts, and then by having this overall dashboard view. That's all with the presentation I have, guys. So I'll quickly move into a Tableau platform and then show it to you. How did we create and how do we read the dashboard, and then how did we create a story overall of the data, whatever we have. Quickly gonna start with the input data. In the presentation we started up, and then I said that we have analyzed the input data in the two stages, two machines, which is for the blower, which is for the labeler. So this first chart talks about the blower performance for the hourly wise. The first one I'm just gonna show it to you in animated view. So this is how the blower performance looks against the days, against the time and the reading. So this is where you can see the stoppages. This is how the performance of the blower goes. And in the right side, we have created the forecast by using the Tableau native methodology. The same thing has been implemented for the labeler machine as well, where you will have a view to see how the labeler machine is performing with the readings against time. And of course, you can see when it comes to blower, the labeler has got more downtime. So this is just analyzing the data and then coming out with some inferences, how the data looks like. And then we have user forecasting, native forecasting for both blower and the labeler machine. Right, so this one talks about the performance of all the machines. Like we have come out of the inferences as well, that there are a few machines which has got the similar performance. I think we spoke about these two machines, filler and then labeler. We also spoke about CO2 having the downtrend performance. We also spoke about the blower and then preform. These both machines performing a little similar. So this is how the machines are performing. This is a dashboard where we have compared the input data, blower versus the labeler. You can see this is the labeler performance where we have got more stoppages compared to blower. And these are all interactive dashboard where you can actually go and then check what is that reading of the blower when the labeler was not working. So if there is any similarity between the blower and labeler, in the same way, if we have to perform a comparison between labeler and then the filler like we spoke, so you can probably have a similar kind of a trend for those two machines. So this is like an interactive way of checking if there is any similarity or differences are there between two machines, right? So I would probably want to share one more dashboard for input data. Right, so this is a dashboard which talks about or which shows the blower performance for 12 hours, and you have an interactive dashboard here where you can see the performance of the blower and then the labeler for 24 hours. The same way, there is another dashboard where you can even see for the performance of the blower for 2 days. Right, so this dashboard just shows us the where you can track the where you can have a view of performance for 24 hours, so that you can have more detail of the readings and then probably understand where is the problem. Right. So that's up with the input data dashboards we have created, guys. And I will probably quickly jump into output dashboards now. Just give me a second, few seconds for that. Right. So there are so many stories we have created. I will walk you through a few stories which are presented in the PPT. This is the first story of the output data where we have used the statistical approach and have calculated the average, and then we have calculated the lower control limit and upper control limit, and then as I said that we have considered 1 Six Sigma level, right? So this is so in interactive dashboard where you can even change the sigma level and then can understand what is that when is that machine performing out of the control limit. If you see here, there's something which is below the lower control limit and then upper control limit. These are the problematic areas here when it comes to labeler performance. And then here again, there are places where the blower is having a bad performance, right? As I said, if you probably go back and then change the sigma level, you can probably see the difference here, right? So if you are changing the considering more deviance from as per the Six Sigma level, so you don't see it with the labeler any out of control limits, but you can see that blower. So it just completely depends on the client what is that they want to use it. But as I said, if it is 1 Six Sigma level is when you can see the correct performance of machines here. So this is interactive dashboard where we can see both the performance of machines in a same view, right? And then this is an animated view of output data performance. So I'm just gonna show this for you. So we are just looking at the performance of the blower. And here we can see the performance of the labeler. And we can understand the same thing like input data. We can see there's a lot of erratic or downtime for the labeler compared to the blower, especially these particular days from August 21 to 24 for the labeler, and then for August 22nd and 23rd for the blower. So probably we can go back and then understand what exactly went wrong for on those days for both the ideally 22nd, 23rd, what exactly has happened where both the machines were not performing. Right, so this is a overview of animated charts, right? And this is a comparison of blower and labeler performance when it comes to output data. So the first story we have considered the SPC approach, and then there is one more story we have created where you can have a reference banding, which is the average, and then we have considered the confidence intervals with the 95% of confidence interval. So anything which is not in the 95% confidence level interval is when you will see the problematic areas here. So this and all is the data points, but whatever you see above the band 95% band is where you will see a problem with the blower performance. And this is the hourly performance of the blower, and this talks about the moving average moving average of the blower, and then this the last chart talks about the running sum of the blower. So this is a completely statistical approach of monitoring any machine, how is it actually working and where is the problematic area. And then we have, like I said, we have considered the reference band and then confidence interval into consideration and created this dashboard. The same thing has been implemented for the labeler as well, right? So whatever you see here, grayed out area is the confidence interval of 95%. And this is you can even see this is very interactive dashboard, guys. So where you can just click and then understand what is the reading and then how did the labeler perform. I mean, if you probably can go back and then pick up that machine, and then for this reading, if the machine has not labeled correctly, so you can understand that this is not the ideal the reading rate for anything to have a correct prediction. So this is again average, moving average, and then the last chart talks about the running sum of labelers so that we can see the performance of this machine. Right. So as I have showed you in presentation, this is a dashboard view where you'll have everything on one place. Like I said, when it is a live environment, when the data is getting uploaded in real time, you can actually see if there is something going bad. So if this is what the blower performance, if there is something is going wrong with it, and if it is coming to zero level, so we can go back and the monitoring team can go back and then take the corrective actions and then fix it immediately than letting the damage to happen. So these are the dashboards and the stories we have created for the data what we have got, right? Probably now is the time for Sharat or Manish to take over and then check if we have got any questions from the viewers.
We don't have any questions till now, so we'll wait for a minute. If you guys have any question, you can ask. And this project is of utmost importance for the production team. So like that we have forecasted in our output data also. So if there is any issue in the labeler or blower, beforehand we will know and we'll replace it without any breakdown. It will reduce the cost of replacement also. So if there is a breakdown, we'll replace it. It will take some time. So beforehand we will know when there is a breakdown and we will replace it beforehand only. So if you guys have any question, do ask in the YouTube chat window. We have a question here. So Akash Naskar is asking, which data set are we using? Salma, are you there? Will you be taking this question or shall I take it?
What is that question, Tahir? We have what?
So Akash is asking, which data set are we using?
Yes, Akash. So it is a time series data set where the performance of machine is being measured in hourly and then daily basis. Okay. Are you able to hear me? I'm actually answering it.
Yeah, you are audible actually.
Okay.
Yeah.
Yes, yes, I am here. I am.
Now you're not audible. So let me answer this question. So Akash, we have taken a data from a soft drink bottling process. So the data is from the production process. So in production process, right? In soft drink, there is a CO2 also in soft drink. In lab, there is a labeler and blower. So we are interpreting the data and checking when that blower and labeler has stopped working, or we are also predicting when it is going to stop, so that it can be replaced before and only. I think I have answered your question. If you have any question, do ask in the chat. Okay, I think we don't have any further questions. So Sarath, I will be handing over to you.
Tahir, let's give few more minutes for viewers to ask any questions, and meanwhile, Manish or Sharad take over the
Sure.
close. Yeah. Tahir, do we have any more questions from the viewers?
No, we don't have any further questions.
Okay, I think we have Manish. Yes, Manish, we have finished the presentation. We have even have taken up the Q&A session. So if you can go for a close for us, please. I think, guys, with that note, thank you very much. And we have finished this presentation. And I again want to thank Sharad for helping us, and then Sandeep for mentoring us, and the entire team. Thank you, and then appreciate all the efforts you have put in for this project. Bye. Bye, everybody.